Hello, Math 1. This lesson's on identifying and writing explicit rules for geometric sequences. Okay, so first, real quick, you guys have learned about what a sequence is before, and it's basically a list of things or numbers that are in a specific order, and you have to remember that you always start with the first term. Okay, and these are patterns that repeat and allow us to write what we call an explicit rule for. Okay, and we'll talk about this a little bit, but you guys have already talked about these when you did arithmetic sequences earlier. So what we're going to do here is take the pattern of dots we have here, right? When we're starting at 1 minute, 2 minutes, and 3 minutes, how many dots we have at each one, and answer the questions that follow. So how many dots will there be after 5 minutes? Well, most people would say, okay, after 1 minute, I have 6 dots. After 2 minutes, I have 12. After 3 minutes, I have 24. And they're just going to say, what am I doing each time? 6 times 2 is 12. 12 times 2 is 24, right? So to find after 4 minutes, I would do 24 times 2. It's 48. So after 4 minutes, there would be 48 dots. And after 5 minutes, all I'm going to do, 48 times 2, there would be 96 dots after 5 minutes. Now, if we were to try and write a sequence that represents a number of dots, so if I ask you, how many dots are there after 20 minutes, you don't want to keep multiplying by 2 to figure that out. We want to create like a formula here. So the easiest way to look at this is if I went from 6 to 12 to 24, okay? If I look at this, that starts at 6, but this would be 6 times 2, and then this would be 6 times 2 times 2. Right? Because 6 times 2 is 12. 6 times 2 is 12 times 2 is 24. And then if I did the next one, right, you know you had 48 dots. That would be 6 times 2 times 2 times 2. So if you look here, your first term, your second term, your third term, and your fourth term. Okay? Your first term is 6. Your second term is 6 times 2 to the first power. Your third term is 6 times 2 to the second power. Then your fourth term was 6 times 2 to the third power. Now notice here, your exponent is always 1 less than the term you're working with. So to write this formula, we're going to say this would be 6 times 2 to the x. And what we're going to do is our exponent is always 1 less than our x value. So we do x minus 1. So with this, I can create a table by saying the first, after 1 minute, there were 6, 2 minutes, 12, 3 minutes, 24, and so on. And then we said the function rule for this now we could create would be 6 times 2 to the x minus 1. We're going to make this a little easier down the road here. Okay, what this describes is when we have a pattern where we're multiplying or dividing to get the next term, 6 times 2, 12 times 2, right? And then I know the next one would be 48 times 2. What this is, it's a geometric sequence, a sequence in which each term is found by multiplying or dividing the previous term by what we call a common ratio. And if you look at the pattern down below here, here's your first term, your second term, your third term, fourth, and fifth, where A is always your first term. R is always going to be your common ratio. That's basically what are you multiplying by each time. Multiplying or dividing, sorry. Now your explicit rule, right, would always be f of x equals A, your first term, times your common ratio to the x minus 1. So anytime we want to write the explicit rule, you just need to know the first term, the common ratio, and write your formula. All right, so let's look here at a couple of things. How do we look for if it's geometric or not? Well, here's the sequence given to me. From 5 to 25, 25 to 125, 125 to 625, what do we do? Well, 5 times 5 is 25, 25 times 5 is 125, times 5 is 625. Are we multiplying by the same number each time? Yes. What's our first term? Our first term is 5. And our common ratio, what are we multiplying by each time? Is 5. So for the next example, if you look here, from 343 to 49, 49 to 7, 7 to 1, 1 to 1/7, what are we doing here? We're dividing by 7 each time. That means this is also geometric. Our first term here is your 343, but your common ratio, you have to understand that dividing by 7 is the same thing as multiplying by 1/7. So our common ratio we're going to use is 1/7. Now the last one here, from 8 to 12, 12 to 16, 16 to 20, are we multiplying by the same thing each time? No. Therefore, it's not geometric. That one you're adding for each time, which makes it arithmetic. But here's the thing I want you guys to see, right? If I were to create and fill out this table, and how I'm going to fill it out is I'm going to start with plugging 0 in for x. So I'm going to get 2 times 3 to the 0, which is 2 times 1, because anything to the 0 power is 1. 2 times 1 is 2. If I plug the next one in, 2 times 3 to the first power, that's going to give me 2 times 3, which is 6. Notice here in this formula, you're not starting with the x minus 1, right? You're just raised to the x power. Anytime you have the 0 term, right, you don't have to do to the x minus 1. However, if I wanted to start with the first term, my initial amount would be 6. My common ratio, what am I multiplying by each time? 3. So I could do 3 to the x minus 1. This would be an alternative example or formula to use for this table. Okay, now what I want to do here is I kind of want to get through further examples, right, without running out of time. So let's take a look here. What's your first term here? Well, my first term is negative 12. My common ratio is, what am I multiplying by each time here? Well, negative 12 times 6 gives me negative 72, times negative 6, or times 6 would give me negative 432. So what's my common ratio? 6. Now, remember, every sequence starts with the first term, second term, third term, fourth, and fifth. So my explicit rule is my first term, negative 12, times, what's my common ratio? 6. Because I'm starting with the first term, I have to raise this to the x minus 1. So if I wanted to find the value of the 8th term of the sequence, right? Negative 12 times 6 to the 8 minus 1. 8 minus 1 is 7. And if I plug this in my calculator, I would get negative 20,155,392. Okay, now what that means is if I kept multiplying by 6, that's the number I would get. Okay, so let's take a look here. To find this explicit rule of all of these sequences, I have to recognize right away that 6 times 3 would give me 18. 18 times 3 would be 54. 54 times 3 is 162. So my first term is 6. So f of x equals my first term. What's my common ratio? 3. And because I'm starting with the first term, I'm going to raise that to the x minus 1. Okay, now the next one, to go from 9,072 to 1,512, what am I doing? I'm dividing by 6. Here, dividing by 6. here, dividing by 6. So that right there tells me my common ratio is 1/6. So f of x equals my first term, 9,072, times 1/6 to the x minus 1 power. And letter C, 3 times 5 would give me 15. 15 times 5 would give me 75. Times 5 would give me 375. So what's my rule going to be? Well, f of x equals, my first term is 3. My common ratio is 5, so 3 times 5 to the x minus 1. Now you have to understand, I only raise it to the x minus 1 if and only if I'm starting with term number 1. Which means here, in example 4, you have to recognize that they're giving us the 0 term in this one. So if I'm given the 0 term, I can say my explicit rule is the value of y, which is 2, times, what's my common ratio here? I'm multiplying by 3 each time. So it's going to be 3 to the x power. So if I use the 0 term, I don't have to raise it to the x minus 1. So in the next example, am I given the 0 term? No, I'm given the first term. So I'm going to say my explicit rule is my first initial value, 8. What's my common ratio here? What am I multiplying by each time? I'm multiplying by 2. So my common ratio is 2. And because I'm starting with the first term, I'm going to subtract 1. Now, in the next example in the table, if I'm given the 0 term, that's the one I want to use. So here, my 0 term is 4. So my function rule or explicit rule is going to be the initial amount or first term or 0 term. What is my common ratio here? Well, to go from 12 to 4, I'm dividing by 3. From 4 to 4/3, I'm dividing by 3. So my common ratio, remember, dividing by 3 is the same as multiplying by 1/3. So it's going to be 1/3 to the x power. I don't have to subtract 1 up top because I am starting with the 0 term. So the next one. Find the first 4 terms of a sequence whose common ratio is 7 and first term is 3. So if I start with 3, now to get the next term, 3 times 7 is 21. 21 times 7 is 147. And the fourth term would be 147 times 7, which is 1029. The next one has a common ratio of 1/3. And the first term is 972. So my first term is 972. My second term, I'm going to do 972 divided by 3, right? Which is going to give me 324. I'm going to divide that by 3 to get 108. Divide that by 3 to get 36. And that's my fourth term. Now the next one. Find the first 4 terms of the sequence whose first term is 9 and the second term is 36. So first term 9, second term is 36. Well, what did I do? If I know it's geometric, right? What times 9 would give me 36? 4. So to find the next term, multiply that by 4. 36 times 4 is 144. Now I'm going to multiply that again by 4. 144 times 4. The fourth term in this sequence is 576. All right, hopefully this is good enough to help you guys with the student practice worksheet. Let us know if you have any questions.